Alright, so in this video we're talking about solving quadratic equations by factoring. Now some of you are really just going to struggle with factoring because you weren't good at it in Algebra 1 when you first learned it or were supposed to learn it. And you know, it's just not easy. I wasn't that good at it when I was in high school, but you need to get good at it because it's probably, out of this whole course, it's probably the most useful tool that you're going to carry with you for the rest of your math classes from this point forward. So you need to get good at factoring. Alright, so binomials are just two pieces. It's just some terminology here. Trinomial is three pieces. And then factoring is we're going to break down an expression into its smallest pieces possible. So break into smallest pieces possible. And then what we're going to focus on first is how can we use factoring to rewrite a trinomial. So how can we rewrite an expression that has three pieces in it? Okay, so here, this is a trinomial that has three separate pieces, x squared, negative 12x, and negative 28. That's a trinomial. Okay, so what I want to do now is factor it, break it down into its easiest pieces. So what I'm going to do is I call it the EZ method because all I'm looking at are the factors of c. So remember, I'm looking at ax squared plus bx. So this method, this is called the EZ method because it's easy. Alright, so and this is just x squared plus bx plus c. That's the what we're looking at. So first off, we're looking for factors of c. Factors of c. So we're just going to list those out. So we're looking at 28. So we have plus or minus, because we need to consider both. 1, 2, 4, 7, and 28. There's, let's see, 14. Forgot 14, you need to put that in there as well. And it's important that you get all the factors. Don't make a mistake like I almost did and leave out a factor. So this is a 4 here. Okay, so now what I want to do is I've got what's called a double check. Okay, and this is our double check. I need to find two factors that add up to b. So two of these factors that we just listed out that add up to b, and then also multiply to give me c. So I need two factors that add up to b. Well, 14 and negative 2 should work. So let's try 14 plus negative 2. These two factors do add up. So these two factors add up to positive 12. I don't want positive 12, I want negative 12. So let's try a different combination. So maybe negative 14 and positive 2. So negative 14 plus 2 is negative 12. That's my B, so I've got my first check done. My second check is I need to see if these two factors that I'm using multiply together to give me C. So negative 14 times 2 equals negative 28. And that is my C. So these are the two factors I need to use. So my final answer then, breaking this down, is x minus 14, and then x plus 2. Okay? And that's equal to our original expression, so x squared. So this is equal to x squared minus 12x minus 28. And you can verify this using FOIL the box. Now that was pretty easy. I'm not going to work through all of it anymore. I'm just going to give you the answer, okay? Because once you get good, you can do this in your head. But if you need to go back and practice the steps, come back and refer to this example. Okay? This is a different type of thing. In that previous problem, we didn't have anything for A. It was just x squared plus bx plus c. Now we have ax squared plus bx plus c. So I call this the AC method. Because what we're going to do is first list out factors with an A times C. So we need to first figure out what AC is. So find A times C. Okay, well here, A is 3, C is 10. So we have 3 times 10 is 30. Next, we're going to list factors list factors of AC. So in this case, we're listing factors of 30. So plus or minus 1, 2, 3, 5, 6, 10, 15, and 30. Again, we have to consider plus or minus. We also need to be sure we list out all the factors, because if we miss one, that might be the special combination that we need. So be sure you take a few seconds to make sure you get all. Now what we need to do is go through and do our double check again. So far, pretty similar to what we just did with the easy method. Okay, so the next step is double check. Alright, so what I want to do is first I have to pick two of these factors in this list that add up to my middle term, so negative 17. And then those two factors also have to multiply together to give me A times C. So I need to pick two of these factors that add up to negative 17. So negative 15 and negative 2 add up to negative 17. So negative 15 plus negative 2 equals negative 17. So that's my first check because that's my B. And then I also need to make sure that these two multiply together to give me AC. So negative 15 times 2, or times negative 2 equals positive 30. That's AC. So I've done my double check. Now this is where it gets a little bit different. What I'm going to do now is I'm going to take these two middle terms to rewrite my original expression. So my original expression was 3x squared minus 17x plus 10. Now I'm just going to rewrite that right here. So this step right here is called split the middle term. Okay, so again, I'm just going to rewrite my original problem, 3x squared minus 17x plus 10. And what I'm going to do is take these two factors and I'm going to split this middle term. So negative 17x is what I'm going to rewrite. The other two pieces, the other two terms stay the same. So 3x squared. Now I'm going to say minus 15x minus 2x plus 10. Okay? So notice negative 15x minus 2x is still negative 17x. So I haven't changed the problem any, I've just rewritten it. So now I'm going to use what's called factor by grouping. Okay, I'm going to use the box. Okay, so use the box. Use the box to factor. And what's nice about the box is it works anytime you have an even number of terms. So here I have 4 terms, which is an even number, obviously, so I can use the box. So I need a 2 by 2 box. And what I want to do is put this time, since I'm working backwards, I want to factor, I'm putting my terms on the inside, and the order doesn't really matter. So 3x squared minus 15x minus 2x plus 10. Now I say the order doesn't matter, but sometimes it does. Okay, so sometimes it's not going to work out perfectly, which we'll see later on, and you're going to have to change the order of your box. No big deal. So just plug it in. Hopefully you'll get lucky the first time and plug it in correctly. If not, just rearrange. It's not a big deal. We'll see it later on. All right, so now what we want to do to factor this is we want to look for common factors, or GCF, the biggest thing we can pull out for each row and each column. So I'm just going to do the top row first. So the biggest thing I can pull out is 3x. And then the second column, the biggest thing I can pull out is a negative 2. For the left-hand column, the biggest thing I can pull out is an x. And then for the right-hand column, the biggest thing I can pull out is a negative 5. Okay, now, unfortunately, this box method is not perfect. So what we have to do now is we have to verify, using the box, that we have all 4 of these terms, okay? So 3x times x is 3x squared. I'd like to put a little check mark so I know that I have it. 3x times negative 5 is negative 15x, so that's good. I've got that piece. X times negative 2 is negative 2x. Then finally, negative 2 times negative 5 is positive 10. So we got lucky and it worked out perfectly the first time. Sometimes it doesn't. So now we're done. So we have our final answer. So our final answer, x minus 5 times 3x minus 2, and that's equal to 3x squared, our original problem, 3x squared minus 17x plus 10. Okay, it's a little bit longer, okay, but once you practice, that's all it is. Okay? Now, sometimes we're going to have patterns, and if you know the patterns, it saves you a lot of time. There's actually two patterns here. So this is called difference of two squares, or just dots. So, difference of two squares. Okay, because I have a squared minus b squared. Difference means minus. The difference of two squares. So, if you have something a squared minus b squared, if you have a problem like that, then it simply factors into a minus b times a plus b. Okay, and we'll do an example of this coming up, but this is just a pattern. I strongly encourage you to get this memorized. Okay, and then also what we have over here is we have a perfect square trinomial. Okay, this is called perfect square. So perfect square trinomial. So what it means is it's going to work out perfectly. So all we're going to do is say it's a plus b quantity squared, or it could work out a minus b quantity squared. And all it depends is, do we have plus or minus here? So this is a squared plus 2ab. Let me actually write that out. That might be helpful for you. So if I end up with a squared plus 2ab plus b squared, then that's equal to a plus b, that whole thing squared. That's the pattern you need to know. Or if I end up with a pattern like this, a squared minus 2ab plus b squared, that's equal to a minus b quantity squared. Again, you need to get all three of these memorized, okay, because it saves you lots of time. All you have to figure out is what's your A and what's your B. Okay, so let's do an example. So here, I have two pieces. So far, the only method we've learned about two pieces is dots, difference of two squares. So this is dots, because that's the only pattern we have that uses two pieces. So hopefully it's going to work out a squared minus b squared equals a minus b times a plus b. Okay, so first thing I need to do is figure out what's my a and what's my b. So what I'm going to do is try to match this up with my pattern. So here, a squared would be 4x squared, and b squared would be 25. Notice I'm not worried at all about the negative. Don't worry about the negative. It's just this piece and this piece. All right, so I don't want a squared, though. I want a. So what I have to do to get rid of the squares, take square root on both sides. Okay, so square and square root cancel out. So I have a is equal to, let's take this one piece at a time. Square root of 4 is 2. And then again, square and square root cancel out. So a is equal to 2x. So everywhere I see an a, I can put in a 2x into my pattern. And then I'm going to do the same thing here. I don't want b squared, I want b. So I got to take the square root on both sides. So square and square root cancel out. So I know b is equal to square root of 25, which is 5. So everywhere I see a b in the pattern, I'm going to put in a 5. So just plugging into the pattern now. So I had 2x quantity squared. I'm just plugging into the pattern right here. Minus 5 squared is equal to this. So I have 2x minus 5, 2x plus 5. Okay, let's make sure we have the original problem by simplifying over here. 2 squared is 4. X squared is x squared minus 25. So that's our original problem. So 4x squared minus 25 is equal to this. So this is our answer. That's how we factor it. 2x minus 5, 2x plus 5. Pretty easy if you know the pattern. Okay, so here, factor. Well, we have a trinomial, and it's ax squared plus bx plus c. Okay, so we could go through and do that long pattern that we just talked about, but let's try, and hopefully we get lucky, and hopefully we have a perfect square trinomial. So what I'm hoping is happening is we have a squared plus 2ab plus b squared. And if that happens, then we know it's just simply a plus b quantity squared. Because if we can make this pattern work, then that saves us a lot of time, saves us a lot of work, instead of having to go through the whole problem that we just did a few minutes ago, where we had to go through and split the middle term and all that stuff. Okay, so let's try to first figure out what a is. So, based on this pattern, okay, so a squared is equal to 9y squared, and then b squared is equal to 16. I'm just matching it up with the pattern. Well, just like we saw in the dots problem that we just completed, we don't want a squared, we want a. So what I have to do is take the square root on both sides. Okay, so square and square root cancel out. So I know a is equal to square root of 9 is 3. Square and square root cancels out. So y. So everywhere I see an a in the pattern, I can plug in a 3y. No big deal. Same kind of thing going on down here. I don't want b squared, I want b. So everywhere, so square and square root cancel out, so I'm just left with a b. Square root of 16 is 4. So everywhere I see a b in the pattern, I'm going to plug in a 4. So let's go ahead and use that pattern now. So I have 3y quantity squared plus 2 times a, which is 3y times b, plus b squared. And that's supposed to, if it works out, it's supposed to be equal to a plus b. So 3y plus 4, that whole thing squared. Well, what I need to do is check, make sure I get back the original problem. If I get back the original problem, then I know for a fact that the pattern works and that this is my answer. So I just need to simplify each one of these. Okay, so 3 squared is 9, y squared. 2 times 3 is 6, times 4 is 24, so 24y. And then 4 squared is 16. Now let's just go back and check. That's what we had originally. It is. So yes, the pattern works. So we know that this is my answer. Again, it saved us a lot of time because we knew what that pattern was. Now, if you forgot the pattern, what you would have to do is you have to go back here, ax squared plus bx plus c. You would have to find ac, list the factors of ac, do your double check, split the middle term, and then use the box. Lots of extra work. But you would have gotten at the same answer. It just takes a little bit longer. Okay? This one, let's try that. We're going to do the same thing because now, again, I have ax squared plus bx plus c. But what I want to do is try to make it look like one of my patterns to save some time. So what I'm hoping happens is I have a squared minus 2ab, because I have a minus in the middle, plus b squared. And if this pattern works, then what's going to happen is I have a minus b quantity squared. That's going to be my answer. So what I first need to do is figure out what in the world are my a and b. So I know, based on this pattern, a squared is 49 r squared, and b squared is positive 1. Well, again, I want a, so I got to take the square root on both sides. So square and square root cancel out. So a is equal to square root of 49 is 7. Square and square root cancel out. So a is 7r. So everywhere I see an a in the pattern, I'm going to plug in 7r. Do the same thing for b. Take the square root on both sides because I just want regular b, not b squared. Square and square root cancel out. Square root of 1 is just 1. So everywhere in the pattern I see a b, I'm going to plug in a 1. So what I need to do now is just go ahead and plug in. So what I have is 7r quantity squared minus 2 times 7r times 1, because that's my minus 2ab, plus my b squared. And if this works out, then I should end up with 7r minus 1, that quantity squared. So what I need to do now is make sure that I get back the original problem. If I get back the original problem, then I know the pattern works and I know that this is my answer. Okay, so 7 squared is 49. R squared is just r squared. Negative 2 times 7 is negative 14 times 1, so we have minus 14r. And and then 1 squared is 1, so plus 1. Let's double check, make sure we do have, in fact, the original problem. 49r squared minus 14r plus 1. So the pattern worked, so that means that this is my answer. Saved a lot of time. Again, if you didn't remember the pattern, you got to go back and do that AC method. Find the factors of AC, do your double check, split the middle term, use the box. So this saved a lot of time, a lot of effort. Okay? What's a monomial? A monomial is just one piece. And then how do monomials help us factor? Well, they help make the problem easier. Okay, so factor 5x squared minus 20. Well, what you always want to do first is see, do you have a GCF you can pull out? Do I have a common factor that can be pulled out? This one, yes. So first, always look for the GCF, the biggest thing you can pull out of both. I can pull out a 5 for both of these. So I have 5 on the outside. What remains is x squared minus 4. Well, now I'm not quite done because I always need to double check what's remaining. Can I break that down anymore? And actually, yes. Hopefully you're paying attention. You know that's a dot. So this part is dots. My difference of 2 squares, so I have a pattern. So it's a squared minus b squared equals a minus b times a plus b. Okay? And I'm not going to go through the work on that for you. If you need help with dots, go back and check out that problem. So what the inside factors into now, so I have x squared minus 4. That factors into x minus 2, x plus 2. So my final answer is 5 times x minus 2, x plus 2. I can't do anything else, so this is my final answer. Remember, factoring means to break it down as much as possible. Pretty easy. Okay, same thing going on here. I always want to start by look for common factor. Look for your GCF. Here my GCF is 3. Okay, so I can pull out a 3. So remaining here is 2p squared plus 5p plus 3. Okay, and this one actually we have to do the AC method now, but we're only doing the AC method for this piece up here. So this is the AC method. So we know first find AC. So I'm just looking at this piece squared in blue. So I know my A is 2, my C is 3, so AC. So we have 2 times 3, which is equal to 6. Next, we find the factors of AC. In this case, for this particular problem, AC is 6, so we just need to find the factors of 6. So plus or minus 1, 2, 3, or 6. Now we need to do our double check. Okay, so our first check is that we pick 2 of these factors in this list that add up to our B, so 2 of these that add up to 5. Okay, so 2 and 3, that's pretty easy. So 2 plus 3 equals 5. And we also need to do our second check, which means these 2 factors we're trying to use has to multiply to give me AC. So 2 times 3 does equal 6, that's my AC, so that works. So these are our 2 magic factors that we're going to use to split the middle term. So split the middle term. Okay, so our middle term here was 5, so we want to split that up. Okay. And I keep forgetting what the problem is. I'm sorry. So 2p squared plus 5p plus 3. So I'm just going to write that first. So 2p squared plus 5p plus 3. And I'm going to split this middle term. Okay, so this is what I'm rewriting using these 2 factors. Okay, so I end up with 2p squared plus 2p plus 3p plus 3. Notice I didn't change the value because 2p plus 3p is equal to 5p. So now I'm going to use the box. Because I have an even number of terms, I have 4 terms, so I use the box to factor. Okay, so I have 2p squared. Oops. And don't forget when you're using the box, don't make a mistake I just did. You've got to put all your terms on the inside. So 2p squared, 2p, 3p, and then 3. Okay, and I'm looking for the GCF for each row and each column. So for the top row, the biggest thing I'll pull out is a 2p. Bottom row, the biggest thing I'll pull out is a 3. Left column, the biggest thing I'll pull out is a p. And then the right column, the biggest thing I pull out is a 1. Okay, so what I need to do now is to just check and make sure I get back all 4 of these terms. So 2p times p is 2p squared. 2p times 1 is 2p. 3 times p is 3p. And then 3 times 1 is 3. So I got lucky this time and all 4 pieces work. So my final my answer is 2p plus 3 times p plus 1. But this is not my final answer because remember at the very beginning I pulled out a 3 from the original problem. So I still need that 3 to be represented. So I'm putting it just on the outside because I pulled it out at the beginning. So my final answer is 3 times the quantity 2p plus 3 times the quantity p plus 1. Okay? And then finally this one. So I have 2u squared plus 8u. All right, well, I always, again, look for GCF first. Okay, so 1. Look for the GCF. Well, the biggest thing I can pull out here is a 2u. Don't just pull out a number. Sometimes you can pull out variables, so be aware of that. So what I have remaining here is u plus 4. Well, there's nothing that can be done with this piece. Nothing that can be done with this piece. So that's all that there was. I got very lucky with this particular problem. Nothing else to do. So that's my final answer. And then finally this one. Always again, look for GCF. Okay, so here my GCF is 4. So on the inside I have x squared plus x minus 1. Okay, and what I'm looking for is I have a trinomial. Well, we could try to, there's no a here, so I could try the EZ method, the very first thing we learned, but I could also try to use a pattern. I could also try to use a pattern, so hopefully it's a perfect square trinomial, so a squared plus 2ab plus b squared. And if it works, I know it's going to be a plus b quantity squared. So what we have to find is our a and our b. So I'm not going to go through that. If you need help with perfect square trinomials, go back a few slides, rewind the video, go back and look at it. But here, if it works, a is going to be x, and then b is going to be -1. Or sorry, b is going to be +1. Okay? And so b is -1. So what's going to happen is everywhere I see an a in the pattern, I'm going to plug in. And then everywhere I see a b in the pattern, I'm going to plug in. So hopefully it works. Let's go ahead and try that. So I have x squared plus 2 times x times -1 plus -1 squared. And if it works, I get x minus 1 squared. Okay? Well, what I need to do now is just simplify. Well, x squared, I get x squared. Great. 2 times x times -1, that's -2x. It doesn't work. So unfortunately for this one, the pattern didn't work. Okay? So the pattern does not work for this particular problem. And it's because of this piece right here. The pattern doesn't work, so what that means is this piece right here cannot be factored. So this is actually called prime. So like prime numbers, this piece can't be factored anymore, so we're actually finished. This is our final answer. That's as much as that can be done. Okay? What's a quadratic equation? So a quadratic equation is just something where we have 0 equals ax squared plus bx plus c. Zero product property is what we're going to do is take each factor. So set each factor equal to 0 and solve. And then how can we use the zero product property to solve quadratic equations? Well, we factor and use the zero product property. So very quickly, this one, okay, x squared plus 3x minus 18. The first thing we want to do is factor. Okay, we've already done lots of factoring, so what we need to do now is factor this guy. So I'm looking for, this is the easy method if you want to do it. So this is factors into x plus 6, and then x minus 3, and it's still equal to 0. If you need help factoring, you need to go back and rewind the video. So now using the zero product property, I'm just going to take each one of these factors and set it equal to 0. So x plus 6 is equal to 0, and x minus 3 is equal to 0. Okay, so I just solved. So here x equals -6, that's one of my answers, and x equals 3, that's one of the answers. Now, this is nice. Solving this is very nice because what we're doing is we're finding the x-intercepts of the quadratic function. So if we replace this 0 with a y, we just found the x-intercepts for this quadratic function. So anytime we find the x-intercepts, sometimes that's called the roots, sometimes that's called the zeros, sometimes that's called the solutions. Okay? What we're doing is we're solving the quadratic equation. Okay? Everything works out great. Okay? And that's it for this video.